The world continues to spin in its usual way, but with every spin today, the pace of change seems to escalate. My name is Sue Rofe. I'm Professor of Architectural Engineering here at Heriot-Watt University, and I'm just an ordinary architect, an ordinary engineer. When I was born, the world had 2.6 billion population, and today there are more than 7 billion people in this world, so the challenges are more enormous. And as times change, these huge alterations have come about in the way we live in our ordinary homes. In the 1970s, most of the houses in Britain were run or heated with coal, and that's coal or coke. And suddenly, within a decade, with the oil crisis of the 1970s, all that changed. And homes today are largely heated with gas central heating. So that's 40 years, and it's been a complete revolution in how we heat and power our houses. But the trouble is, for every ton of coal we burn, for every litre of oil we use in our cars, or cubic metre of gas we use in our homes, that's been having knock-on effects. It's been driving a change in the anthropogenic emissions or the man-made emissions of greenhouse gases, and that in turn has begun to alter the climate we live in. So we have two challenges as a generation. One is to reduce the amount of fossil fuels we burn, and the second is to adapt to climate change, with all its manifestations, the increasingly extreme weather events like floods or droughts or heat waves, extreme storms that fell trees in our landscapes, and the forest fires that eliminate or threaten whole cities now. So how do we do that as a generation? It's not only physical environmental challenges we're facing, but there's also social and economic knock-on effects. So if you take the ordinary engineer here, in her ordinary lifestyle, with maybe her husband, or if it's a him, with his wife and children, in their ordinary home, the global economic crisis has meant that there's been a huge and growing rate of unemployment even amongst the middle classes now. So what happens if the engineer loses their job and the family suddenly has a hugely reduced income to live on? How do you live a comfortable life in rapidly changing economic times? Well, in order to build a robust society, the government's been investing in huge, for instance, offshore wind power or biomass systems or huge hydroelectric power schemes. But how does that actually affect you in your ordinary home? Because you're still buying the energy, you still have to pay the bills at the end of the month. So if we take a growing problem, fuel poverty in the ordinary family, one of the things that we're striving for in the built environment is to see how we can create comfortable ordinary homes where people can live secure, healthy lives and yet run on energy they generate themselves from the house. So if you take an ordinary house like this, we can put solar panels on the roof to generate electricity to heat our water, and we can increase the insulation in our homes. So we've got nice thick walls with triple glazed windows, and that significantly reduces the amount of energy you use in the house. But there's a whole next generation of technologies that are coming online to look at the house as a sort of ecosystem with all the flows through. So we can begin to use the water we put through the house, for instance the bath water and the shower water, to take the heat out of that to heat the mass of the building. You can not only heat the house with the solar gains that come in through the windows, storing it in the mass of the house, but you can use the heat from cooking and from the lights and from the hot water to retain that heat within the system. Then you can run your rooms on high efficiency LED lighting, which means that instead of 100 watts to light a room, you're using 5 or 10 watts to do the same work. And then if we go downstairs into the kitchen and the living room here, you can start to look at what work is being done in the house. So we've got the cooking here. You can start to run your cooker and your stove on, for instance, high efficiency electric cooking, which you can run off your solar roof. You can then leave the stew in the oven during the day, change your lifestyle and behaviours, and have controls. That means that the oven comes on, or the dishwasher or the washing machine, when you're generating your own electricity. You could redesign fridges so they turn off at night, and then they only start cooling when you're generating your own energy. You've got a whole range of equipment in that house where you can begin to start to tailor the technology and your lifestyle to maximize the impact of generating your own electricity, because the advantages of that, you never have to pay for electricity again. And I know this from my own house that I've written about in this book, where I was the first photovoltaic roof in Britain and could then run my own electric car off the solar roof. So you can start to actually provide your transport through your own solar energy too. So it's a revolution. It's got huge challenges, whether you're a psychologist studying behaviour, a sociologist studying fuel poverty, an economist studying the costs and benefits of these whole systems. If you're a technologist, an energy expert, an electronics engineer, a transport engineer, a planner, the challenges are huge. And finally, what you do get is the ordinary lifestyle and the ordinary home, which might not look any different at all. But what it is an energy, an approach, and an environmental philosophy and a lifestyle for low carbon living and low carbon buildings that will revolutionize the way we run the world, and offers the ability to provide a resilient society for the future. So where better than in Scotland? Don't forget, we led in the 18th century, the Industrial Revolution. The 19th century, engineers like Stephenson and of course James Watt, after whom this university is named, they developed the steam revolution, the Industrial Revolution. So what about the low carbon revolution? And it's really important that all of you are part of it. So we look forward to you as the young innovators, the inventors, the creators of the new world order for creating the low carbon future we need in a rapidly changing world.
Okay, my name is John Kissick. I'm chairman of the Industry Leadership Group for Forest Industries. I guess to many of you, you'll not be familiar what the forest industry actually is. Well, it spans everything from the growing of trees through timber processing and all the way through to timber frame manufacturing, furniture manufacturing, pallets and packaging, a whole range of different end uses for timber. We also embrace the timber importing sector because still the bulk of our material comes from overseas into this market. A major depletion of our forest resource after 2 world wars led the government to invest a substantial sum of money creating new forests both in the state and private sector. This they did through various incentives that they gave to growers to allow us to create a reserve of timber in case we have future wars. And that legacy has allowed a number of major processors to invest substantial money in new processing capacity. Indeed, £500 million has been spent in the years 2000 to 2010, putting in new capacity and up-to-date machinery. Approximately 19,000 people are employed in our industry, with the same again employed indirectly in transportation and other support services. It's not a small industry by any manner of means. While the perception of the industry may be that it's a low-tech, agricultural-based sector, the reality at the production end is something quite different. The industry has invested heavily in the latest technology, so it's no longer a physical activity to convert timber into, or trees into timber. It's actually much more based on high-tech systems of automation, PLC control, 2- and 3-dimensional scanning systems, which allows us to maximise the quality and yield of material from our raw material. But forestry isn't only about economic outputs, although it's easily measured in terms of economics. It's also about other areas, including forest tourism, and that means a lot to our local rural environment. It's an important area. So what does all this mean for the Young Innovators Challenge? Well, the forest industries represent a genuine opportunity to help the Scottish Government meet its policy objective of creating genuine low-carbon economy. Too often we equate low carbon with renewable energy, wind farms for instance, and changing people's behaviour to reduce energy use in the home. These changes in attitude are not easy to achieve. Trees and timber products provide some of the only true low carbon and sustainable building materials for the construction industry. The process of photosynthesis within the leaves and needles of trees is nature's way of absorbing CO2, converting it to oxygen for release back into the atmosphere and locking the carbon away in the wood fibre. The only added ingredient required is sunlight. Forestry in Scotland is the only industry which can demonstrate a positive contribution towards mitigating our CO2 emissions through carbon sequestration. So any expansion of well-managed, productive forestry will help improve our position. But perhaps more importantly, if we can then use the timber products produced from these forests in the built environment, we can lock up that carbon for the life of the building, say a further 70 or to 100 years. Off-site construction techniques such as timber frame systems have great potential to maximise carbon storage, but equally important, through good quality design and erection, we can realise even greater benefits. For example, the standard family house in Scotland costs an average of £1,400 per annum to heat. An equivalent, well-designed timber frame construction can reduce that annual bill to £250. Now that reduction in energy consumption makes a real contribution to our climate change targets. But that's all fine and good when we are dealing with new build. But what about our existing housing stock? Currently we tackle this through support schemes which are aimed at improving insulation through either the cavity walls or the loft. Again, a laudable objective until you consider that some of the products used for this purpose are very energy intensive and in their manufacture and may well involve raw materials which come from the petrochemical industry, products with low sustainability credentials. My challenge to you is to look at our existing housing stock, review the building products which are truly low carbon and sustainable, and for me that would be obviously timber based, and try to develop innovative solutions aimed at making the step change to the fabric of our buildings which would lead to lower energy consumption. This is not an easy challenge. If it was, then we would have numerous solutions already in operation. Get it right, we not only support the efforts to meet climate change targets, but we also have the chance to eradicate fuel poverty in many of our poorer communities. I hope you will give this serious thought and good luck in your thoughts.
I was interested in how timber can be used in different ways to replace existing materials. Maybe you could tell me a little bit about what's happening.
Well, there are all kinds of new products coming along in timber, engineered products mainly. So going away from the standard sort of raw material and using it just as sawn battens. And now we're getting lots of engineered products, so flooring systems. We're getting things called cross-laminated timber, which is solid timber structures. And they replace whole walls rather than using a concrete wall or a steel combination type operation. And these walls have superb thermal insulation and also good noise insulation. So these types of products, particularly in Central Europe, are now finding a lot of traction. And we've now done some work here in Scotland producing such products out of our own homegrown material. So we're quite optimistic there might be some development down that way. There are also developments at the other end, sort of looking at the structure of timber and the chemical structure of timber and seeing if we can break out certain materials from within cellulose to be used in other areas. So for instance into textiles. There's quite a prospect that we go down that road and find other very, very good added value uses for timber products.
Okay, so if we think about the preeminence of plastics, for instance, in our everyday environment, I suppose it would be quite interesting to find alternative alternatives to plastics, perhaps using timber-based products?
There are alternatives already available. I mean, I went a number of years ago to the United States, and there they are already extruding timber products. So they are taking very fine timber particles, mixing it with recycled plastic in small quantities. So the bulk of the material is 70-80% timber particles, and then they add recycled plastic to that to produce something that's equivalent to an extruded plastic element. So that's starting to help, and it's reducing the demand for plastic, and it's using a recycled plastic product. So these things are actually happening. Initially they did a lot of the work replacing existing timber products, so they were using it for decking, using it for window type frames, this type of application. But I'm sure there'll be other things that will come along in due course.
Alright, okay, and so in textiles you could actually have your whole house could be timber right down to the curtains.
It's possible, but I don't think we're quite at that stage yet. But certainly they're looking at some quite exciting developments. I certainly, in my office, I have a handkerchief that's made out of timber particles.
Right.
I was giving to me at one time, but I've heard about shirts being made and various other things. But these have been very much experimental.
Okay.
Stages, but there's prospects for real change.
Okay, thank you.